Okay, so thank you very much for accepting to give this Cesabinar. Mehdi Adjeraoud, who is working at the IRD in Perpignan in south of France. Was one of the principal investigators of the SCORE-REEF group, and his research fields are the structure, dynamics, and conservation of coral reef communities in the Indo-Pacific. He also works on the influence of environmental and anthropic pressures on the resilience of coral reef communities. He works on understanding mechanisms regulating coral reef populations, and he also works on developing tools and indicators to characterize coral reef health and resilience. And Valeriano Paravicini, you work at the École pratique des hautes études, the CRIOB, also in Perpignan in France. You were the other PI of SCORE-REEF, and you work on functional ecology, biogeography, and coral reefs. And you also work on the trophic structure of coral reefs, on estimating ecosystem processes, and quantifying fluxes of energy and nutrients on coral reefs. Thank you very much. And now, if you want to start your presentation, the floor is yours. Thank you.
Okay. Okay. Thank you, Camille. So yeah, so this is the first slide here is just to introduce you to the SCORE Reef program. It was a CSAB program, so it was funded by the FRB, the French Ministry for Ecological Transition, and Office Français de la Biodiversité, donc OFB. Biodiversity Office, but I don't know if this is a good English translation. Anyway, the idea was to find a way to discuss and to find a good strategy to develop ecological indices to evaluate the status of coral reef in France. So here, this is the main problem. As you know, France has several overseas territories, some of which are in tropical coastal regions, so there are coral reef associated. Some of these are overseas territories, and some of these are even department of France, and so are subjected to European laws such as the Water Framework Directive. Whatever the legal instrument, France has the responsibility to manage these ecosystems, and so this is why ecological indices that define the status of coral reefs become useful. However, it's very challenging to develop ecological indices and which are relevant for conservation because in the end we take ecological indices are basically one score. And so it's nice to have a score. It make things easy, but we dramatically reduce the complexity of the ecosystem. And when we speak about coral reef, which is the most diverse marine ecosystem in various biogeographical regions, so with different evolutionary histories, finding one ecological score that can capture the status of coral reefs is extremely challenging. So what is done so far in France and in several other parts of the world, but in France, we are basically reducing the complexity of coral reefs to three main indicators, which are so in terms of definition, I consider here indices, ecological indices, the scores, so the final index. And I consider indicators all the variables that are used to build the index. Just to be clear, because I know it's different. Other people may have different definitions. So we have three descriptors or three indicators of coral reef status, and that are basically collected everywhere, not everywhere actually, but in most places. But they are really simple. So we have basically algal cover, coral cover, and herbivore abundance, and when we are lucky, we have biomass. So these basically are the three indicators. So we basically collapse all the complexity of the coral reefs ecosystem. We put up on lenses that really simplify the system and allows us just to see these three components. This may seem weird for someone who's not used to study coral reefs, but actually it has some roots in the scientific literature and the historical scientific literature. So this is a very influential paper from David Bellwood. He published in Nature in 2004, and you can see that basically it's one influential paper, but there are several other papers, and this is not the one which actually proposed that, but it's just an example. There is this in the scientific literature in coral reefs. There is this, I would say, tradition in thinking that healthy coral reefs should look like this. So basically, there should be high coral cover, high fish biomass, and this is one stable state of coral reef. And then if we stress the reefs, we are going to drop in other states, which may be more or less stable. So we can go to macroalgae, tarphialgae, sea arching barrens, but this is how we traditionally we see the system. So the view we have in the system is from the literature. The view we have of coral reefs is basically a system where there is a benthic component and a fish component. The benthic component is basically there are two communities which compete, which are algae and corals, and then there are herbivores which decide more or less where this equilibrium is going. So the fact of having the three indicators that we commonly employ in our monitoring makes sense according to the literature. However, there are some problems which become evident when we compare different biogeographical regions. As you have seen in the map before, France has territories in several biogeographical regions, and coral reefs in the Caribbean may be dominated by sponges and being more or less healthy, or anyway, moving from the Atlantic to the Indo-Pacific is there are really different biogeographical and evolutionary histories, and so considering the system as equivalent and looking at them with the same lenses may not be the best strategy to have an overview of the system for the management. So this is the working hypothesis we had at the beginning when we wrote the grant actually. Then things changed a little bit, our approach changed a little bit. We maintained the same concept, but the working hypothesis that we propose that there are several types of coral reef, and we consider that there is global variability in the evolutionary history, and so we should embrace this regional level variability and account for it in developing ecological indicators that may be relevant for the management. So here is you can see the main working package, the main programs we have. So there was a first part. So our goal was actually to evaluate which kind of indices are employed presently in France, see which data are presently available, and to reevaluate how to propose how we consider that coral reef should be evaluated in the future. So our approach was to actually prepare a data set. So we wish to build a data set with temporal time series and a large scale global spatial data set. and basically discuss ecological indices that are presently used, define the ecological regions that are homogeneous. So this is what more or less I was trying to say before, the Caribbean type and the Pacific type. Anyway, identify a homogeneous region that may be used in our analysis to compensate for the different biogeographical histories, evaluate time series trend, and then propose a conservation plan. This was the initial plan that we had, and we didn't go to work package 4. I can explain later why. So now I leave Mehdi. I stopped sharing, so I let Mehdi introduce the work he has led in the project, which is the global synthesis. Thank you, Mehdi.
Thank you, Vade. I'm going to present you one specific action within SCORE-REEF, which aim to evaluate, expertise, and try to propose some improvement of the French monitoring done in COREEF in overseas territories. So there are mainly three different objectives. The first is to evaluate what is going on right now, currently, try to see the positive aspects, try to see also things that need to be improved, and also how these monitoring actions meet the public policy objectives. The second one is to examine precisely if this monitoring respond correctly to three main national and international requirements. And the third one is to propose some ways to improve this monitoring for the next years and decades, and more specifically to propose a unified index that can correctly evaluate the ecological status of these reef communities, and also to estimate the potential for resilience and recovery of these coral reefs. So one of the problem with this monitoring is that they are supposed to correspond to three different policies objectives. So we have IFRECOR. A lot of person probably know IFRECOR. It's mainly the ICRI, the French ICRI, who is in charge of the main monitoring like GCRMN around French territories. We have SNAP, Stratégie Nationale des Aires Protégées, and also the DCU in French, the WFD, the Wet Water Framework Directive by the European Community, so at the European international level. The problem, well, not the problem, but the fact is that these different policies have been implemented at different time, and they have different objectives. IFRECOR, for example, is in charge of the monitoring and to communicate at the national level every 5 years on the health, the status of coral reefs, and also their resilience capacities, and is also in charge of attaining that the objective of 100% of coral reef under effective protection. And this IFRECOR concerns all French overseas territories. In contrast, the WFD has started a little bit later in 2011, and the goal of this policy, of this environmental policy, is to maintain or restore the good ecological and chemical status of water bodies by 2027. And So this policy is only for the French department, not French Polynesia, not New Caledonia. It's only Réunion, Mayotte, Guadeloupe, Martinique, and Saint Martin. And for this WFD, the things are very strict, very difficult to attain. In fact, we'll see that a little bit later. But just very briefly, we need to have a standardized sampling network with a gradient of the anthropic pressure that we want to measure. We need to have some reference conditions or reference state. Of course, we need to collect data on species abundance and biomass, and also on environmental data. Most importantly, and one of the most difficult part, is to build some relationships, strong relationships between human pressure and ecological status, which implies that we need to distinguish between the natural and the disturbances that are directly from related to human activities. And after that, you have other things that we need to do, like aggregation of metrics and also validation phase, which is very difficult because it needs to be on another database. So, oops, all right, okay. Just briefly, because I have about 10 minutes to synthesize that. We'll have there is a paper that will be submitted soon. Briefly, what we have at the scale of France is very, very different monitoring programs, not only in terms of implementation dates. So we have, for example, the oldest one in Morea, which is the Tiaoua Radial, managed by the CRIOP in 1979. And the most recent ones for the DCE, for the WFD, in 2017. And this has implication in terms of reference conditions, of course, because as you probably know, the major large-scale disturbances occur from the 80s. So for the Tiaoua Radial, we can have a kind of pre-disturbance state, where for the other one, it's already within the phase of large-scale disturbances. We also have various origin. Some have been implemented for research objective, like the Tiaoua Radial and the CRIOP, and other one for political reason, like the UNESCO in New Caledonia or DCU, for example. And these monitorings are managed by either researchers, like again, the CRIOP, also private consultants, bureau d'études in French, and sometimes by citizen science. So this has also a lot of implication in terms of level of expertise, the level of the data set that we have at the end, and also on data exploitation and valorization. For example, the data set of the CRIOP has been largely published in high-profile journals, whereas other monitoring have never been published. We also have, and this is a major point, a strong variability in the level of monitoring effort and sampling strategy, not only in terms of the number of study sites, but also in terms of habitat habitat sampled, the frequency of survey, the methods, the variables, etc. And this has, of course, strong implication in terms of data analysis and interpretation. And also what we see is that some important variables such as coral recruitment and herbivory are not always taken into account in this monitorings, which is a problem for IFRECOR, who has the objective to estimate the resilience capacity. And most of the a part of the resilience should be estimated with this kind of data, coral recruitment, because the recruits are at the origin of the recovery, after a disturbance, and herbivory because it controls the algal biomass. So in this graphic, we have all the variables or descriptors, as Vali said, indicators that are collected in the monitoring in French overseas. So we have divided this by 4 regions and by the benthos above and the fish communities. I'm not going to go into the details, but what we can see is that we have a lot of variables, in fact, 57 in total, but only 19 are common to all monitoring. And another point also is that some of these variables have been never are collected, but are never analyzed or interpreted at the end. So one of the major constraints to fulfill the national and European requirement is first a lack of a unified index that integrates not only ecological but also functional processes and able to give information on the health of these reef communities and also on the potential for recovery and resilience. What among the different problems that we have is that it's very difficult to identify a reference point, to determine other thresholds, and to, more importantly, to distinguish between natural and anthropogenic source of disturbance. And also what we found is that there is a strong difference between the allocated remediation time that is present within the WFD requirement and the recovery rates, the natural recovery rates of reef communities. So in this figure that is coming from Morea, where we have a long data set, a long time series on coral cover here. So just to illustrate the difficulties that we have with the coral reef ecosystem. Okay, we have this long data set before the onset of the major bleaching and cyclone frequency. So in Morea, we can say that, okay, the reference conditions, the reference state is a coral cover about 50%, because we see that it was the oldest point, but also the maximal value that we have after cycle of decline and recovery, like in 2003 here. And this is not the latest figure, but we can see also a recovery here with something around 50%. But so we can say that, okay, 50% is the reference state. But this is not really true, because as you probably know also that with these disturbances, we have a transformation of reef communities with some coral taxa, for example, that decline and never come back. And the community here in 2003, for example, has the same coral cover than the one in 1979, but with a clear, distinct composition. So these questions are central to this policy, to this environmental policies. What is, how can we define a reference state? So within this, the SCORE-REEF project, we identified some of the way to reduce the variability in monitoring approach, and we gave recommendation for that. But one of the major aspects was to work on integrative indicator to estimate the state and resilience of coral reef. So we have done a work in the Indian Ocean, in Réunion, in the southwestern Indian Ocean, and also in Madagascar. So we used a method called TOPSIS for technique of order preference by similarity to an ideal solution to calculate a recovery index. And this index was based on data not only on coral species richness and abundance, but also on juvenile coral density, which is a proxy of recruitment, on coral cover, also on proportion of stress tolerant coral species, algal cover, but also herbivory fish biomass. And we also included a proxy of the of thermal stress with the sea surface temperature anomalies. And we have tested this air recovery index in two contrasted situations. One along the gradient of anthropization in the southwestern Indian Ocean with Mayotte, Réunion Island, Rodrigue, and some of the îles Éparses. And also we tested this recovery index in Madagascar, comparing this RI in MPA and outside MPA. So we have tested this area. So just briefly, I'm not going to spend a long time, but this approach consists of a set of different steps. So the first is to define a multi-criteria decision matrix. It consists of choosing the right variables or descriptors. So we saw that in our case, we included not only data variables on abundance or diversity, but also on function like herbivory, and also on the potential for recovery with the coral recruitment. Then you have a step of normalization. You can give different weight to each of these variables. For example, if you decide that your index should preferably estimate resilience, you give a higher weight to recruitment, coral recruitment, for example. And then you calculate distance from ideal positive and negative solutions. Positive solution is like the more you have coral cover or coral diversity or coral recruit, it's better for the ecosystem, the communities, and for the resilience. In contrast, the negative solution is that when you have a high algal cover, it is generally not good for the resilience capacities of this ecosystem. Then you have a method a step to calculate a distance, and then you end up with a recovery index, which is comprised between 0 and 1. And if it's close to 1, it's a high potential for recovery. And if it's 0, it's not good for the ecosystem. Just briefly, an example, because it has a lot. I don't have time to go into the details, but it has a lot of good points for managers and policymakers. The first is that it gives you an index at different spatial scale. So we had 3 different regions around Madagascar. So you can have a RI at different spatial scales. And then you have for each of your station a synthetic index RI, which is good for manager, but as Vale said, it's not really precise for other objectives. But the good thing is that we have the synthetic data, but we also have with this radar plot an idea of the different metrics that we have here. Again, coral diversity, abundance, coral cover, herbivory, recruitment, etc. So it has the advantage to give you a synthetic number that is useful when you make a lot of comparison among different regions, but it's also possible to have at the same time the precise data that are at the basis of this calculation of RI. So briefly in conclusion, so we have identified some limitation of this monitoring in French overseas territories, but they, however, remain important for the surveillance of the reef ecosystem, and they contribute to the base knowledge of stakeholders, policymakers, and scientists. And what we can conclude is that they quite well meet the expectation of IFRECOR and SNAP. But in contrast, our synthesis is very clear. These monitoring are not made to respond to the very strict expectation of the WFD because of many things that I don't have to go to detail, but identification of a reference point, determining again our thresholds, the distinction between natural and anthropogenic disturbances is totally in contrast with the major characteristics of reef ecosystem, which are highly diverse, highly dynamic, and complex, and which is very difficult to distinguish, for example, what is really the impact, what is causing the dynamic of these communities. And I will finish by saying that okay, most of this monitoring are based on classical methods, but as you know, there is a lot of progress in the methods with the recent advances in satellite-based remote sensing, eDNA, photogrammetry, artificial intelligence, etc. And also the fact that we have now more and more data on mesophotic coral ecosystem, which are something very important in terms of ecology and functional of the shallow coral reefs and also on their resilience. So all these things herald a new era for coral reef monitoring and call for the establishment of interdisciplinary workshop groups dedicated to integrate these new tools for future monitoring framework. So, in other words, what we have done is a step, but in few years we need to rethink about how we monitor these coral reef ecosystems. Thank you. So now it's Vale who will finish the presentation.
Vale, we can't hear you.
Ah, okay.
Yeah.
Do you
Sorry,
see
you need to start over what you
presentation?
were
No, no,
saying.
thank you, thank you.
Yeah.
Thank you. Okay, sorry. So yeah, right after I mean the first part, made led, which is the critical evaluation of ecological indices which are presently employed in France, and the data available, the monitoring program available, we try to tackle this question, which is, are we able to characterize the status of coral reefs? Yes, I think so. We are able to characterize to define more or less the status of coral reef with different taxonomical resolution, different component, etc. But the question behind developing indices and using indices and indicators is, are we able to put uh, coral reefs in an univariate dimension along a gradient that goes from bad to good. So are we able to input this judgment on coral reefs, and can this be useful for management? So to do that, we collected two main data sets. So the first data set is a spatial data set, which basically has coral component, coral communities, benthic communities, both surveyed in the same locations, at the at quite high taxonomic resolution. So fish are monitored, are recorded at species level, corals not, but at the genus level. And there is quite a bit of detail in the benthos, and we have a fish body size. The temporal data set that you see on the map is quite impressive. No, we have a lot of time series more or less globally. Yes, but basically what we have there is coral cover. That's it. We don't have much more. There are a few time series that have quite good resolution on the benthos, but the fish are not considered. There are quite a few time series where fish are really well surveyed but benthic community is not. For instance, what we are doing in French Polynesia, we record only coral genera, but we don't have any idea about any algae. So it's really inhomogeneous and heterogeneous and complex to merge. So there are only few time series where we have in the same area at good taxonomic resolution, both benthic and fish communities, for instance. So we used, given this heterogeneity, we used two extreme approaches. So we said, okay, let's use a very simplified approach where we basically marry the idea that coral reefs can be described as a coral-dominated state, algal-dominated state, with herbivore and or some fish. Okay, that's it. And we have that a lot of data with this information. We forget about any taxonomic resolution. We just speak about coral, algae, and fish. And let's see what we can describe. At the other extreme, let's take fewer data, just data where we have the highest possible taxonomic resolution, and let's describe the ecosystem according not to the taxonomic identity of species, but the work which is done by the system, which is describing several ecosystem functions. So, and we said, okay, let's see what we can do with these two extreme approach, and let's see where they converge or not. So the first analysis on what we can get with the simplified view of the system was just published in Global Ecology and Biogeography and was led by the first postdoc who worked on this project for 1 year, which is Simon Brandl. Excellent postdoc. He recently, a few years ago, got a permanent position in the university in Texas. So the idea behind this was, okay, let's describe the status of coral reefs according to three indicators: coral cover, algal cover, and coral cover, algal cover, and fish. And we do not even need for fish to have the taxonomic identity. We do not speak even about herbivore because this is another part is questionable for some research. So let's take just, are they small? Are they large? So small fish, big fish. This give us the possibility to define basically four states, which are coral-dominated system with small fishes, algal-dominated system with small fishes, algal-dominated system with large fishes, and coral-dominated system with large fishes. So when we put this information in a principal component analysis, this is what we get. And if we use, this is for the corals and this is for the fish. And even with this, I would say, extremely simplified view of the ecosystem, we have an extreme heterogeneity. So everything is continuous. Here we even had to drop, to create category, to drop a good chunk of data available that were not possible to allocate in the two categories. So here we try to kind of divide the benthic community into coral dominated and algal dominated, and this was hard. even if these were the indicators. Anyway, we managed to do that, and we did that. The same thing is with fish. So we wanted to separate small fish and large fish. And again, even if we have a very crude characterization of the fish communities, this principal component analysis is very continuous, and we had to remove a chunk of the data. Anyway, so there are coral dominated system, there are algal dominated system, and these things, these states of the ecosystem exist. So they can tend to attract, but there is a kind of gradient in all that. So it was hard to obtain. Anyway, we did it. And as expected, we first tested if there was a biogeographical gradient in this. And we see that, for instance, in the tropical instance Pacific and in the Atlantic, we tend to have more algal-dominated communities with both fish and etc. And in the Indo-Pacific, the other way around. Anyway, there is extremely high variability everywhere. So all the states of coral reef, which we can define, are present basically everywhere, and in sites which are just few hundreds of meters apart. So can we predict with environmental variables and human impact, which are the probability for a coral reef of being in one state or in another state? Yes, we can. There is a significant trend due to latitude, depth, chlorophyll, wave energy, and human impact. So in general, human impact tend to remove a large fish component and increase the small fish component due to overfishing, and the environment tend to work in a different way. When we have a lot of nutrients, we tend to be in an algal-dominated state. When we are in a more nutrient-poor environment, we tend to have some corals with small fishes in general, which are probably planktivorous species. And if we test that, they are planktivorous species. So there is some predictive capacity, but again, there is a huge variability. And we looked also at the time series. We standardized the time series. So every time series start from 0 and goes to 1, whatever. So from the beginning to the end. And again, we can kind of delineate a trend. In particular, there is a trend, algal community, algae and large fish communities tend to increase, and coral-dominated states tend to decrease. That the likelihood to get a coral-dominated states tend to decrease through time, more or less everywhere. But again, there is huge variability. So at the beginning of the time series, at the end of the time series, yes, we have these global trends, but still reefs can be in any state, whatever the gradient. And this is true for the spatial trend and for the temporal trend. So let's see what we can get with ecosystem functioning. So with ecosystem function, there were 3 people that were really key to this. Nina Schiettekate, who worked mainly on reef fishes, and she was PhD student in my group a few years ago. Jeremy Carlo, who is here, and he was postdoc in the SCORE-REEF project, and Mike McWilliams, he was a partner, but really someone who really, I think he did, basically with Jeremy, they developed a completely entirely novel way of estimating ecosystem function that did not exist before the project. So thanks to these guys, because otherwise it would not have been possible. And so anyway, for reef fishes, what we could estimate was production, turnover of biomass, herbivory rates, planktivory rates, excretion of nitrogen, phosphorus, and that. For the benthic communities, the accretion, cultivation, storage of carbon, rugosity, branch space, so there's the provision of structural complexity, gross primary production, organic growth, and these are the functions that were computed. So for this framework can be applied on community data if we have enough taxonomic detail. So for each species in our data set, we had a number of traits that allows us basically to apply a bioenergetic model. And this bioenergetic model basically tells us how much a species fish needs to grow in a certain time frame, how much food needs to grow as expected, and how much nutrient will ingest or excrete in doing that. So basically, fluxes applied to bioenergetic modeling that allows us to compute the contribution of each individual fish to the elemental fluxes on coral reefs. Sorry. For benthic communities, it was a mix. Data came from the PhD of Jeremy, who worked mainly on the calcification of corals and how the calcification of corals change through the ontogeny, and Mike McWilliam, PhD. So basically, they assembled a data set and they were able to devise a way to estimate the functions that I just mentioned. And then we applied that to two datasets. The first dataset is the spatial dataset, which is really homogeneous. It's the Reef Life Survey dataset. And otherwise, we applied it on 3 time series, which has the same characteristics. We have benthic data at high resolution, fish data at high resolution, and we have a drop in coral cover and a recovery. So that was the idea. So from this analysis, so we estimated that globally. So here we are seeing the spatial analysis. So in blue, the blue are the fish functions, and these are the benthic function. It doesn't really matter if you read what they are. All of them are more or less unimodal. So we think, okay, again, we tend to see in whatever function, so when we add complexity, there are no two different systems that function in different way. Otherwise, we would expect a bimodal distribution. No, there is a continuum of function, and our reefs are more or less everywhere, and they peak in the intermediate level. So we have most reefs that do the intermediate level of the job, and there are no extreme. So this is what we get from just a graphical approach, a visual approach. Then we tried to, with the principal component analysis, to reduce this complexity. And it ended out that we ended up with 4 PC principal component axes that explain like 80% of the I don't remember exactly, but like 80% of the global variation. And here we see a couple of interesting things. So the first PC axis basically explain this one explain fish biomass. So all the functions are highly correlated with this, and it's fish biomass that explain this. And the turnover is, I mean, since it's biomass independent, it's on the other axis. Benthic function, on the contrary, all of them, algae and fish and coral, whatever, benthic functions are on the second axis, which is explained basically by this benthic total cover, I would say. Then we start to have a discrimination in the third axis. We start to have algal functions and coral functions, which tend to separate. And in the fourth axis, we tend to have the functions that are performed by small fishes. So we tend to have planktivory and turnover, biomass turnover, but because they grow really, really fast. So here what we see, and what we will see later as well, is a complete, and we didn't expect that, a complete orthogonality between benthic and fish community. In the coral reef literature, we tend to believe that basically coral creates structural complexity, and then this is favorable for fish, so we will have high biomass. Actually, the data doesn't see that. So if we look very pragmatically at the data, there is basically no relationship between fish biomass and coral cover, and there is basically no relationship between benthic and fish functions. They are orthogonal, completely orthogonal. There are a few exceptions, and the only exception I see is basically plantivory, who has a kind of weak relationship with a few uh, um, functions that are related, benthic functions that are related to the structural complexity, to the habitat. Because planktivorous fish are really small, they tend to stay in in the branches of corals. So these may be an interesting perspective to look at, but this is quite weak. It exists, but it's weak. Um, and again, so we looked at, are we able, even with this extremely high resolution data set, to identify a perturbation gradient? Because if we don't have a correspondence between the status of coral reef and how to say, and the anthropogenic perturbation, it's really hard to develop any ecological indices which are meaningful. And here we see that basically, if we look at the most, the DHV is the degree of heat in wicks. So it's an index of climatic stress that may produce bleaching, and low gravity and high gravity are basically an index of fishing intensity. So if we look globally, there is the low DHV are the basically 5% of coral reefs that are the least subjected to climatic stress the year before the sampling. And so we have this distribution, and it really overlaps with community we can find with under high climatic stress. So there is it's hard to define to find to quantify an climatic effect, and the same is true for fishing. So this pattern exists. So we found a relationship between degree of heating weeks, gravity, no take protected area, all of that, which we really see in the literature. It exists. We found the exact same thing. But what we think we added compared to what exists in the literature is an evaluation of the model performance. So basically, the R square explain how much variance we explain with this model. So the first axis, which is basically fish biomass, so it's an easy variable. We should see should have a high predictive capacity for this. We have like a 0.06 R square if we don't have the environment. If we include a bunch of other environmental variables, we get to 0.1. So we explain 10% of the variation. So these trends exist, but they are diluted in the global variability. So it's really complex, in my opinion, to develop ecological indices on this basis. And this is just to give you a feeling of how this relationship look like. Yes, there are some trends, but basically reefs can have any configuration along the anthropogenic gradient. Then we did the time series analysis, and this is the coral cover of the three time series. French Polynesia, it's really marked. Indonesia, we had a drop in coral cover and then a tendency to recover. In the Seychelles, we had a drop in coral cover. This is just the average. Some sites recovered and some sites didn't. But anyway, they capture a disturbance recovery cycle. And we did the same analysis. So these are the PC axis. So we can see that it's really idiosyncratic. So there are reefs in that basically have one trend. So there are tendency here to increase the secondary production, while in French Polynesia, there is a clear trend to reduce after perturbation, the secondary production. In Indonesia, again, it's not the same as in French Polynesia. And this is true for any function you look at. And even the correlation between the functions changes. It's not the same. So here, for instance, PC4, that is fish turnover biomass, and PC1, fish biomass, are negatively correlated. Here are positively correlated. So there is a lot of idiosyncratic behavior, which is really context dependent. So there is no universal way reefs respond to coral cover and disturbance. So the take-home message after doing all this is, are the coral reef paradigms true? Is this framework justified? So because we are evaluating coral reef and we tend to evaluate coral reefs, considering that there are two states on a scale, and we go on the coral-dominated situation if we have parrot fishes or herbivore fishes. This is what we tend we develop index to capture this. So if this doesn't exist, we have perhaps the need to rethink how we evaluate this ecosystem. And can we say that this is good and this is bad? I'm not sure we can, because we have reef in perfect, pristine situations that are algal dominated. Are we able to increase our predictive capacity? I don't know, but I'm not sure we can put label here. So the practical implication of this, in my opinion, is that ecological indices determine how managers see coral reef. So we select indicators, we really influence the perception that people that look at indicator have of coral reef. So we should be careful in supporting extremely simplistic views of the system that are true because the mechanisms exist. But when they are diluted in all this variability, are we really doing a good job in selling certainty? It is clearly this, it is clearly this. We need more herbivore. We have to fight against algae, because this is more or less what we tend to do, in my opinion, with this simplified view of the system, in saying that any system, wherever, should be like this: high algal cover, high fish biomass, everywhere in pristine condition, we expect we should have this. Otherwise, if it's not this and there is any dystoma, we go here. So we go from good to bad. And if we go to bad, we have to restore. And we know that this is not that linear, and this pattern exists, but I think it's even a bias in the literature. We have perhaps to think, now that we have a lot of data available, it's perhaps time for a more data-driven approach. Because in my opinion, when we marry a conceptual view of the system, if we marry the idea that the system can be described with three components, we just alter the possibility to get something different. So perhaps we should have more data-driven approach, which is less biased by the view we have, where there is no conceptual model, just data speaking. So this is something Lorena, who is listening, is working on. So we may imagine that, for instance, let's say the indicator is coral cover, that we are going to increase with AI and whatever our predictive ability. And then what we can do is to, like, basically use, as they do in medicine, like Z score, where we just say people, in medicine we do not say people, you are sick, that's good, that's bad. There are these indicators that basically account for the variability, and basically they just say, okay, there is this deviation from the population, and they take into account the variability. So basically, for instance, in this case, let's say we are here, we can remove experimentally in the model the human impact, put the system here, take this deviation, but we also consider that here there is this huge variability. And so we can tend to evaluate this deviation according to a set of indicators. So the problem of this is there is huge variability. So large heterogeneity. So far, the model we built were not predictive model. We used statistical model, linear model, GLM, that mm, perhaps we can improve our predictive capacity with other kind of model, but that's the work Lorena is doing. So it was a very interesting project for me. I had the possibility to collaborate with a number of incredible young scientists and senior scientists. So I thank really the funders. I hope they appreciate the job we have done. For us, it was quite, I mean, I'm really happy about what we have achieved. And I really thank all the partners who participated to this effort. And thank you.
Thank you very much, Valerie and Mehdi, for this super interesting presentation. So now we have some time for questions and exchanges. So if people from the audience have questions, please raise your hands using the little tool, the raise hands tool that you have in Zoom. And I will distribute the questions.
Yes, there was a question by Cédric Bachet in the chat. So maybe Cédric, you want to start the question session?
Yeah. Thank you.
Okay, go ahead.
Yeah, thank you for your presentation. Sorry, there is some echo. That's okay?
Yeah, we can hear you. There is a little bit of an echo, but I think it's better now.
My question is short. Actually, I raised my question in the middle of your talk, and it was about the recovery index.
Oh,
At the end of the first half of the talk. Sorry, I think I shall change something here.
Yeah, it's better now.
okay, Cédric, I just read your question on the chat. Okay, so one
The
of the good
question,
points
can we read it out loud, the question maybe?
how pressures and perturbations are associated to the recovery index. Is it possible to predict the recovery or decline based on scenarios of pressure? The 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 good point, one of the good aspect of this TOPSIS approach and the recovery index is that yes, we can add and we can include different type of variables uh, as soon as they are relevant to the question. So in this case, we try to have an index that could estimate both the health status and the recovery. But we also included a proxy of terminal stress with SST anomalies because it's one of the major, as you know, one of the major disturbance on these coral reefs in the southwestern Indian Ocean and on almost coral reefs. But yes, we can add a different type of pressures as long as again they are relevant. And the thing is that we should be careful on the on the equilibrium between what we add in this index. I mean that if you have a disequilibrium between biological descriptors and environmental variables, it may be not appropriate for some kind of health status. But otherwise, yes, you can add and you can adapt this recovery index to different kind of situation where the pressures or the stresses are different, and you can build this index as you want, in fact.
Okay, thank you very much for your question and for your answer, Mehdi. Does anybody else have a question they'd like to ask?
Well, again, in the chat, Laurence Galetti. So, do you want to ask your question? Or
I have no question. It's for my part only a thanks to our presenters. I am legal scientist. I'm working for IRD, and I would like to thank you for this. I consider an excellent presentation, which raises the issue of the, so to speak, the proper use of these studies, these scientific marine studies in the field of binding legal protection of these reefs. And you underline also the underuse of these scientific studies, which are not really taken into account for the indicators supporting this conservation legal instrument or tool. So it's a major issue for this period, and we have to find a new way or new scenario to address this question. Thanks a lot.
Yeah, thank you very much.
Just for information, maybe to go on with that, is that we are the SCORE-REEF group is finishing a review paper, in fact, on this topic, on the evaluation of monitoring in French overseas. So we'll soon have a paper to submit, and well, a classical research paper. But we also had we will also have a technical report that will be disseminated to policymakers and managers in French overseas, and that's why I only took 10 minutes to present this, because I already presented some of the results at IFRECOR for the National Committee in November, and also for the DCE meeting in October. So just to say that there will be some papers and reports on that that will, of course, it's a long paper. So all the points that I just took 2 minutes to present will be developed in this papers.
Awesome. Looking forward to that. So Romain, you had a question. I have to mute myself because we're in the same.
Well, thanks a lot, Mehdi and Val, for your presentation. Very interesting. It's quite impressive the amount of data you analyzed, and with so many different trophic levels and high spatial and temporal extent. I'm wondering, with such, like, from what you said, it seems that it's very hard to make any conclusions, and yet you have one of the biggest data sets. Do you think more data would help? Because you already have such a amount of informations, or more powerful models, but it seems that you already also have a good you have done a lot of analysis. So is there any hope that we understand better such very complex systems such as the coral reefs? And then I'm thinking a bit other systems. What about I don't know, tropical forests, which we have very few data? Is there any hope that such complex systems, which are tropical forests, are as complex as coral reefs? Can we understand them one day, or is it just, I don't know, just a bit of a provocative question, just to have your thoughts on that?
Yeah, thanks for the question. I think we can do better, because I mean, our data set looks impressive. I mean, our data set is other people created it, but anyway, we start to have large scale and data set which are really impressive, but actually the amount on data is not that impressive because we have basically 1,100 samples for the entire world. So this is one, I think we should, with larger data set will allow to increase the predictability. But then I think that what young scientists I know are doing will really improve our understanding of the system, because I think we have the tendency to remain trapped into one view of the system and then follow up uh, saying basically there are some ideas that emerge in the literature, like the phase shift idea on coral reef, that are really influential, and then we follow up for a number of years, and this limited the number of covariates that and alternative processes that we consider, but we don't know the relation. We don't know. I mean, there are things we can do just because if we start considering them. Um, so I have a colleague who is here, Renato, very brilliant coral reef scientist. He's working on estimating the role of plankton. So this is something which can be done in a few years. It's just that nobody did it before. So the data is there. I think we just have to open our mind to the potential existence on other mechanisms that may explain this residual variability, which is huge.
Cool. Thank you. Nico, do you want to ask your question?
Well, I mean, Thomas, you
Or
have
maybe
raised your
Thomas
hand,
first, yeah.
and I'll do the
I was
question.
expecting you to give your space. Very good. Thomas?
Hello, thanks for the presentation. This is more like a open question. What you showed is that there is not a good and a bad ecosystem. You showed that there is different ecosystem with different type of functioning, and maybe the message could be, do we really need to always talk about, okay, this is a good ecosystem, this is a bad ecosystem, or we damage this ecosystem? Or should we just instead find indexes that focus on ecosystem services or ecosystem functions, saying like, okay, we are interested to know if by putting, I don't know, an oil rig here, we're gonna affect production, and then what stakeholders should, or like gestionnaire managers should do is like, okay, we need to measure these services, these services that are interest for us, instead of saying like, oh, by doing that or having a bleaching or whatever, we get going from a good ecosystem to a bad ecosystem with having those phase shifts at some point. But shouldn't we rethink a bit what message we always seeking, like, oh, good or bad?
I think so. I completely agree. I think the problem arises in ecological indices when we start adding labels, when we start saying this is good, this is bad, because we cannot say that with certainty. I mean, I would trust much more a scientist that really knows one location than, even if expert evaluation has his limitation, then an ecological index that comes from data. But there are the problem is that in the framework like water framework directive, these kind of things, you have to do that. In theory, in Europe, we should label things in this bad to good gradient. And if the status is not good, we even pay some taxes, I think, more, because we are not doing a good job. The problem is that the confidence to which we can say one thing is bad and one is good is so low that I don't think it's possible. So I think for coral reefs, and from what we have seen, I think we have all what is needed to. I think what we should do is trying to have a more comprehensive approach that is more useful for managers. Mm, give them something useful because I understand they have to do something. They cannot live in this huge uncertainty without doing anything. So we should provide the instrument, but providing the instrument without escaping this administrative obsession of labeling things, which is basically not useful. This is my personal point of view. It's really personal. So I'm not an expert in this in conservation.
Yep. I don't know, Mehdi, did you want to react to this question specifically or?
Yeah, just to add some comment on this. Yes, the thing is that if we go back to the Water Framework Directive, which is in fact, well, for us, very difficult to follow for coral reefs for different reasons, mainly because of the diversity, complexity of coral reefs. What we need to go back is that this directive was made with continental waters, very simplified ecosystem, and here it works. But the point that you raised, Thomas, on very simplistic categorization like good or bad, it doesn't work for coral reef because it's so complex in terms of different components, different functions, and also because it's an ecosystem that is impacted by local stresses, large-scale disturbances, and it's very difficult to disentangle each of these disturbance, and we end up with something that is completely crazy because it's not only a good or bad state, it's not only the penalties that you may have because you cannot restore the good ecological status, but it's also because the time that you need to go back to good ecological status is completely crazy for coral reef ecosystem because, as you know, we need decades to go back to an initial pre-disturbance state. And all these things are added. And at the end, that's what we concluded our synthesis by saying that for the Water Framework Directive, it's too difficult to go in that direction.
Yep, complex questions indeed. Nico, do you want to ask your question? I think maybe this should be the last one because we've gone over time quite a bit.
If anyone wants to ask a question, you're very welcome. Otherwise, I'll ask some for sure. Okay, so I mean that's an incredible amount of data you're showing us today, Val and Mehdi. Thank you, Val. I mean, you seem to be a little depressed, you know, at the end, like advocating for data-driven theory and not theory-driven data science. And I really like, you know, that humility that the data gave to you, and you're ready to actually start doing theory because, well, for instance, you find a continuum between algae and coral. And so you conclude that there are no, you know, mechanisms at play because you don't get those shifts that are predicted by the theory. But maybe you have to change the theory. Maybe the two-state system is not the right, you know, hypothesis. And so why, for instance, haven't you tried to find more than two states, like not only algae and coral dominated, but you might have some other state? And what about also the scale? Like, you know, the scale at which you do the analysis. If you do too global sometime, you just, you know, shuffle everything and you miss the drivers. So my questions are, one, can you come up with a more elaborated theory of that, you know, system? And second, what about the scale issue? Thank you.
Yeah, I first think I think the mechanism of the phase shift has been observed. It's real. It's just that it doesn't explain everything. If we try to cluster the data, it's pretty weird because we don't get any clusters. So if you ask any clustering algorithm how many clusters are in the data, any algorithm would say there is one cluster. So yeah, an approach, as you say, might be to, yeah. So we did with Jeremy a biogeographical regionalization, which is not completely finalized, it's more or less finalized, but one option might be to, yeah, try to rerun the analysis for regions and by region and see what happened, or something like that. Yeah. That I think may be possible. And I agree, I'm not depressed at all. I just start I think it's I just think we need we yeah we need I'm not depressed at all. I would say it's perhaps I'm 43, so it's perhaps the crisis of the. But I start to question what I did before, because we tend to publish papers to do something. We tend to follow the mainstream, and I think that that's not useful. And I think that was actually what happens with coral reefs research, because we had a sequence of very high impact paper that explained everything with the phase shift. So the phase shift became the dominant process. It's just dominant in the literature. It's not dominant in nature, probably. So I'm questioning what we should do. And I just think we should be open-minded. Yes, I'm sure there are new mechanisms which are underexplored. Yeah.
Yeah, thank you.
Cool.
I was expecting that.
Thank you very much. Are we good? No last very short question? Okay, well, I think we're done then. Thank you very much for this really interesting presentation and for the nice discussion. And yeah, I will now stop the recording and it will be put online in the following week or so on the YouTube channel of the FRB. Thanks, everybody, and keep
Thank you.
posted for next time,
Yeah,
March
thank
7th.
you. Thank you. Thank you very much, Camille, for organizing all this.